Hello, Algebra 1. Today we're going to talk about equations involving factored expressions. One of the basic things we're going to talk about is just the fact that when you have an equation of this form, it's going to have the same solution set as an equation that's joined by or. Okay, so we're going to solve factored or easily factorable equations. All right, let's solve each equation for x. Add 10 to both sides, and I'm going to get x equals 10. So my solution set is 10. Here, if I subtract 20 from both sides, and then multiply both sides by 2, I get x equals negative 40. My solution set is negative 40. Demanding Dwight insists that you give him two solutions to the following equation. Can you provide him two solutions? Well, we just solved x minus 10 equals 0 and x over 2 plus 20 equals 0. And we said that if this equals 0, or if, that equals 0, or then the entire equation could in fact equal 0. It's true, right? So the two possible solutions, if I plugged in 10 to the equation or negative 40, then I would be correct. Demanding Dwight now wants 5 solutions to the following equation. Can you provide him with 5 solutions? Well, yeah, I just need to go 1, 2, 3, 4, 5. If any one of those sets of binomials equals 0, then my whole equation would equal 0. I can do x minus 10 equals 0, therefore x could in fact equal 10. 2x plus 6 equals 0. Subtract 6 from both sides. Divide both sides by 2. X squared minus 36 equals 0. Add 36 to both sides. Take the square root of both sides. And x equals plus or minus 6. X squared equals, x squared plus 10 equals 0, so x squared, subtract 10 from both sides. Take the square root of both sides, and I get an irrational number. So that one isn't valid for what we're talking about. Sorry, I should show you the square root there. Then the last one, x over 2 plus 20 equals 0. We solved in the previous slide. X equals negative 40. So my solution sets are, I'm going to try to list them smallest to biggest. Negative 40, negative 6, negative 3, 6, and 10. Yep, 10. I was worried that we caught that one, which is not a valid solution, not real. Consider this equation. Rewrite the equation as a compound statement. Remember, we said that two binomials next to each other can actually be an or statement. So x minus 4 equals 0, or x plus 3 equals 0. So my solutions are, this one would be x equals 4 because I add 4 to both sides, x equals negative 3. So negative 3 comma 4 is my solution set because it is an or statement. All right, let's get into some meat of things. These are all going to be just a little bit different. We have to factor our equations the best that we can. And when I say factor, I mean we're going to look at this equation and find something that's common between both terms. What can I take out? It's that distribution, sort of the reverse distribution. If I take out a 2x, if I look at this first term, I have an x left over. If I look at the second term, I have a 5 left over. And I can always check my work by saying, if I distribute that back, do I get my original equation? And I do. 2x times x is 2x squared, and 2x times negative 5 is negative 10x. Now, I grab each piece and part, and I set them equal to 0. So this would be equal to 0, or x minus 5 equals 0. Divide both sides by 2, I get x equals 0. Add 5 to both sides, I get x equals 5. So my solution set is 0, 5. Okay, same here. These are the tricky ones that throw some off. I have x minus 3 common to both terms, so I can actually factor x minus 3 out. And in this first term, what I have left is an x. Second term, what I have left is a plus 5. Now I can go ahead and solve it. It's x minus 3 equals 0, or x plus 5 equals 0. Therefore, x equals 3, or x equals negative 5. All right, 3 examples. I'm going to let you guys do these on your own. So go ahead and try them. I'm going to push pause, and you can come back and check your work. All right, take your time and check out each problem. Make sure you got the same answer. And there's 3 more on the next slide. Okay, cool. Okay, I'm going to push pause. You do the same, and pay attention to this one. It's one of those where you can factor a binomial out. Okay, but you can do it. Be right back. Push pause. All right, there you go. Check those out. Push pause and look at them. See what you think. And we're moving on. All right, next example. So we're kicking things up a notch. Consider the equation given. Lulu chooses to multiply through by 1 over x minus 2 and gets the answer of 8. But Poindexter points out that x equals 2 is also an answer, which Lulu missed. What's the problem with Lulu's approach? Well, you can't actually multiply through with 1 over x minus 2 because x minus 2 could actually be 0. And 0 on the denominator is a no-no. Okay, we're not allowed to divide by 0. Okay, so if x minus 2 in the denominator, if you actually had x equal to 2, 2 minus 2 is 0, and 0 in the denominator isn't possible. We can't divide by 0, so we can't do that. So use factoring to solve the original equation. Okay, so this is sort of one of those, pay really close attention, because it's almost like magic. Okay, I'm going to take this entire piece and subtract it from both sides. I'm going to move it to the left side of the equation. Sort of like magic. Now we see I have these that are matching, so I'm going to take those out. And what I have left is 2x minus 3 minus x plus 5. Let's simplify that a little. Got 2x minus x, which is just plain old x, and negative 3 minus 5, which is negative 8. Should have written this up there. So now I can do my OR statement. So now I have x minus 2 equals 0, or x minus 8 equals 0. That gives me x equals 2, x equals 8, and my solution set is a given. And look, 2 is in fact one of the solutions. use factoring to solve the equation. So I'm going to take this whole thing and move it to that side of the equal sign by subtracting it. Minus x minus 2, x plus 1. Okay, now I'm going to push pause and solve it. I want you guys to practice this one on your own and let me know if you get stuck. There's your clue. Okay, there's your solution. Check it out. See what you think. Cool. All right, solve each of the following for x. Okay, we've got an easy one. Subtract 2 from both sides. And set notation. Here, tad bit harder. Let's move this over. We need to set it equal to 0 for us to even work on getting the solution, right? So I have x squared minus 3x equals 0. Now I can factor out my greatest common factor, x and x minus 3. So I have x equals 0, or x minus 3 equals 0, which gives me x equals 3. And then this last one looks like, well, let's erase that. I'm going to take this and subtract it to the other side, leaving me with something equals to 0. X, 5x minus 20, plus 2, 5x minus 20, minus 5. 5x minus 20 equals 0. I'm going to factor that piece out, so I'm going to have one of those at the end. And I'm left with x plus 2 minus 5 equals to 0. 5x minus 20, and then I've got x plus 2 minus 5, so x minus 3 equals 0. 5x minus 20 equals 0. X minus 3 equals 0. Needs more room. So 5x equals 20. Divide both sides by 5. And x equals 3. We can get those written in the right order, right? All right, verify that those are the same. To verify that, I feel I need to FOIL this. So first times first, outer, inner. We're going to see if that equals a squared minus 25. These cancel, and in fact it does. Cool. Now let's try this one. Okay, multiply those. First, outer, inner, and then last. I don't know what 88 squared is. Did not memorize that one. So I have x squared minus 88 squared equals x squared minus 88 squared. We're good to go. Okay, verify these. Okay, we've got a pattern here. We did it in the last two. When I have the difference of perfect squares, a squared and b squared, it factors into a minus b and a plus b every time. Okay, if I just do a plus b, a minus b, if I FOIL that, I get a squared minus ab plus ab minus b squared. The center terms always cancel out. Always. Okay? So this is in fact going to be verified. Because if I FOIL this, I'll have a squared, outer is going to be plus ab, inner is minus ab, and then last will be minus b squared. Those cancel, and I'm left with that at the beginning. Cool? All right, let's do something a little different. Solve for x. So I have x squared minus 9 equals, I'm going to distribute that 5. 5x minus 15. I need to get the letters on one side, the numbers on the other, sort of. So let's move that over. X squared minus 5x, and then add 15. That would give me a positive 4. Nope, 6. Sorry. Cool. Now we have to factor this into 2 sets of parentheses. Okay, it's a little bit challenging. I know I want x's here, but now I need to pick what goes in the second spot. Okay, there's a little trick here. This sign tells me what goes here, what goes here and there, and that one tells me that they're both minus. So if I have a positive in front of the constant, it tells me that these signs are going to be the same, and this one tells me that they're both negative. Okay, so here this says they are both negative. All right, I'll come up with another example where they're both positive or where they're different, but that one says they're both negative. Now I need 2 numbers that multiply together to give me 6, a positive 6, and add together to give me a negative 5. If I put a 2 and a 3, they multiply to get 6, and they add together to get negative 5, which is pretty cool. Now I can solve it. X minus 2 equals 0, or x minus 3 equals 0. X equals 2, x equals 3. Now let's try this one. I'm actually going to FOIL that first. W squared minus 5w plus 2w minus 10 equals w squared minus 4. What's cool about this one is I can subtract w squared from both sides and make my problem easier. Now I'm left with a negative 3w minus 10 equals negative 4. Add 4 to both sides. Oh no. Sorry, we don't want to do that. Let's add 10 to both sides. I get 6 equals negative 3w. Divide by negative 3. W equals negative 2.